Hey everyone, today we're going to talk about our favorite number, letter, and dessert, pi. It appears just about everywhere in our world, in math, physics, and even in our rivers. Let's get to it. First, let's answer the question, what is pi? Suppose we take a circle of diameter 1 meter, and we let this circle roll along a straight line and complete one full rotation. Then the distance traveled by this circle after completing one full rotation is pi meters. This comes out to about 3.14 meters, which is a pretty good approximation for pi. Now, suppose we take a circle of diameter d meters. We roll this circle along a straight line to complete one full rotation just like before. Now, the distance traveled by this circle after completing one full rotation is pi times d meters. What are we really measuring here? We're really measuring the circumference of this circle, the total distance along its boundary. The total distance traveled by this circle after completing one full rotation is equal to its circumference. So we get a nice formula. The circumference of a circle is equal to pi times its diameter. Okay, but what does this have to do with rivers? Well, let's take a look at the shape of rivers. Suppose a river has total curve length or arc length c, and the distance between its starting and its ending point as the crow flies is d. Then the ratio between these two quantities is something we call the river's sinuosity. The sinuosity of a river basically tells us how curvy a river is. A river that's a straight line will have sinuosity equal to 1, and a river that's really curvy has sinuosity that's very high. The fantastic claim that's being made here is that the average sinuosity of all rivers in the world should be pi. How is this possible? Well, in 1996, a physicist named Stolem published a paper in Science that used fluid dynamics to characterize meandering river systems. He used fractal geometry to show that the average sinuosity of a river should be pi. Let's gain some intuition for why this might be the case. If we take a look at a meandering river, then we notice that the curves of this river can be approximated by circles. This circle shown over here has a diameter of d. So, as we saw previously, its circumference must be pi times its diameter. Dividing both sides of this equation by the diameter, we get that c over d must be pi. Why does this matter? Well, we can think of the arc length of this river between 2 points as half the circumference of the circle, and the distance as the crow flies between 2 points on this river as the diameter of the circle. So it makes some sense that the sinuosity of the river may be pi-like. But let's go even deeper. Let's ask the question, why do rivers meander at all? The answer to this question was given to us by none other than Albert Einstein, the man whose birthday falls on Pi Day. Einstein said that the outer currents of rivers travel faster than the inner currents of those rivers on their curves. This means there's more erosion on the outer edges of rivers than there is on the inner edges. So, what does this mean for the shape of rivers? Suppose this is the initial shape of our river. The outer edge will get pushed outward even more, whereas the river will also get pushed inward and get pinched. This is because the water that's hitting the edges of the curve of this river is eroding the riverbank, causing the river to get pinched, while the outer bank is still moving outward. This means that this process continues and rivers get pinched even further and start to move outward, creating loops. Eventually, these loops will short circuit, and when they short circuit, the river will bypass the loop entirely and form what's known as oxbow lakes. Let's take a look at a picture that demonstrates this process. In the left picture that we see over here, this river hasn't short-circuited yet, but has a very high sinuosity. That's because it meanders a lot. It has a lot of loops, and these loops are still intact because the river hasn't short-circuited, so it has a high sinuosity greater than pi. However, on the right, we notice the creation of an oxbow lake. That's because the river has short-circuited and the river is far straighter than it used to be, so its sinuosity is lower than pi. This natural process indicates that the sinuosity of rivers should oscillate between the value of pi. Here's a question for you. Do you think this is true? Do you think that the average sinuosity of all rivers on Earth should be around pi? Let us know what you think in the comments below. Thanks so much for watching and happy learning. Hey guys, if you liked that video and want to see more content from us, please like and subscribe. Tutors for Change is a non-profit dedicated to creating a world free of barriers for receiving a good education. You can check us out at tutorsforchange.org. Don't forget to check us out at tutorsforchange.org/Pi Day to celebrate Pi Day with us with some fun Pi-related activities, including an interactive simulation to calculate the value of pi using random numbers. Thanks so much again for watching. We'll see you next time.